Hey everybody, this is Larry. This is day 13 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So today I took it a little bit easy. I just spent 2 hours in the gym doing just leg presses and nothing too heavy today. Just kind of get the blood flowing after running 32 miles on Saturday. And then just ran like a couple of miles. And most importantly, the one thing that I always do on Mondays that I don't skip is mobility. Just a lot of stretching, a lot of getting my body used to weird angles. So that's basically my day, and kind of just slept a lot to be honest, but still a little bit tired. I guess my body's still recovering. So hope everyone's had a good weekend, and this week will be good as well. I'm gonna do it. I think I am gonna do a bonus problem after this, so definitely stay tuned for that. And without further ado, let's take a look at today's problem. We have 40 combination sum 2. Given a collection of candidate numbers and a target number, find all unique combinations in candidates where the candidate numbers sum to target. Each number in candidates may only be used once in a combination. Okay, so no duplicates, target 8, and you have to kind of just do all of them. I think the one thing to realize is that the size of the output could be exponential, right? So you have to basically keep that in mind when you do it, because you have to keep that in mind because if the size of the output is exponential, you really can't do better than exponential. So that's basically the big thing. And then after that, it's just about trying to do it in a way such that you don't. And for this, that is particular to this problem. And what I mean by that is that it's a combination. And what's a combination? Combination, it just means that order does not matter, right? So here is you go to 161, for example, in a way, but you only count this once. So a natural thing to do is just sort, right? It's basically the idea, and then everything is just honestly brute force in a way. It's a little bit awkward, honestly. I don't, because I think it is going to still be exponential, but maybe there's some like weird Fibonacci thing going on here. I don't know that. I don't know. I don't know how to analyze it honestly off my head with respect to these constraints. I think 30 is also pretty good, right? Because if I have to guess, it is probably something that's like has an upper bound Fibonacci, and that's maybe that makes it a little bit better, but still it is not small, right? And why do I say Fibonacci? Honestly, it's just a gut thing, an approximation that an approximation that's from experience. I don't really have any big thing about it, but you could probably think about the recurrence of the worst case. And I think for the worst case, something like this could be the worst case, given that n is equal to 100. And the worst case is how you analyze, or how I try to kind of think about whether this is good enough, right? So for example, worst case target is equal to 30. I think that makes sense in a obvious way. And then maybe the candidate length for 100, maybe you have like 30. Okay, maybe I don't need to write it all out, but like 30 of these, maybe something like 30 of these, and then I don't know, 3, 4, 5, I don't know, something like that. Maybe maybe even this is. This doesn't do anything because you don't, even this doesn't do anything because this only goes up to 15, right? So then now this goes up to 10 or something like this. And then 4 times 8, 5 times 6, and is that, that's 55-ish, right? Plus 14 is 79, right? 69. Did I mess, is that right? Maybe I should use a calculator. Huh. Okay, that is 69. I don't know how I got 69, but okay, fine. And how I come up with these numbers is, and should be a 7 actually. So okay, so 68. It's just that because there's no use of having 8 of these because you can't have enough 4s to hit 30, right? Because so 4 times 7, something like this. So this is 68, 73. 7 times 4, 8 times 3, right? 9 times 3, 10 times 3, something like this. And this is probably close to 100. I don't know. I lost the math a long time ago. But this is kind of the worst case, right? And you have to think about, well, yeah, how many things are there? There are 10 things, and they're kind of like, I don't know. It's just, I'm doing very hand-wavy math, right? But you can kind of imagine just like having all these as the upper bound, and then let's say you have 3 numbers, right? This you could choose 3 numbers. That's going to be 10 choose 3. I mean, I know that doesn't technically target up to, but you maybe like I would play around with like 10 choose 3. Because you have 10 distinct numbers, and then you choose 3 of them or something like that. Or if you want to, right? You could say, you 10 choose 1, 10 plus 10 choose 2, plus 10 choose 3, plus 10 choose 4, ... And you sum that series, it's just 2 to the 10, right? So this is going to be fast enough for this. But even you want to like add it more out a little bit more, I don't know, right? Then, yeah. So I think in that way, you can kind of... And my math is not very precise because it doesn't have to be. It just has to be worse than the actual number so that it provides an upper bound, right? So that's kind of the idea of how I would think about the worst case analysis. It's not quite perfect, but it's just an idea to think about it, right? And the reason why we can do sort is that so then we can. There are 2 ways you can think about doing these things with respect to how you want to handle only used once. Is that if you sort it, then you can see that once you're done with a number, you're done with that number, right? So in that case, you don't have to like worry about going to a 6 and then going back to a 1. So then this becomes or if you want to think about it in reverse, you're thinking about the normalized version of the numbers or the candidate or combinations. And the normalized version is going to be sorted, so then you don't have to kind of, do duplicate work in any way, right? So okay, so then now here we'll just do some recursively. You could also, I guess, use a stack if you want. And here recursively, maybe I'll just go like, get combo, and then you have the index, which is the index of the candidates that we're caring about, right? And then the current target, and then maybe just passing along the current array, right, that we're using. And then here maybe we have an answer is this, right? And then if index is equal to n, let's also put this here. Then I guess we put if target is equal to 0 first, then here we want to return, if I could spell it correctly, it would be nice. But we want to append current, but keeping in mind that current is an array reference, so you have to make a copy of it. So here, this is how I would make a copy. You guys would use like copy.deep copy or something like this in Python. But in your language, make sure this is a copy of all the objects, not just the reference, which is what happens a lot in Python anyway. But it also happens in other languages, right? Depending on how you pass by the thing. If index is n, that also means that it's not target is not equal to 0. So then now we just return because we ran out of numbers. We don't do anything about it. Otherwise, then this is just a simple thing of take no take. You can actually, you don't need to sort it. You can also use a frequency table and then maybe sort the frequency table. You don't even need to sort the frequency table, I suppose, if you're careful about it. But yeah, this is the way I would do it. And then here it just becomes take, no take, right? And if you take, then what happens? Then it's just get combo, index plus 1, target minus candidates of index, and then current, right? And then here we just have to update current to include candidates index, and then here we pop afterwards, right? Yeah. And then of course the thing to check And you can maybe, I guess, put it here on the if statement, but I like to do it before, especially in Python, just because safer function call. So this has to be, make sure that this is greater than or equal to candidates of index. And of course, why not just put it in here? I don't know. All right, there you go. Right. So that's one to take. And no take, what happens? Then you want to go to the next number. But the next number is not always the next index, right? The next number is actually going to be the first number that's not equal to this number. So how would I want to do that? Next index maybe, right? And then target doesn't change, current doesn't change. And then next index, and maybe you can actually do a for loop here. I think I'm gonna say it's probably fine, though maybe it's a little bit sloppy. Maybe it just adds an O of n, so I don't think it worries that much. But we should just do a thing with next index, right? Next is, and we can, like I said, there are a couple of ways you can do it, but we can just pre-process this, right? Where we don't care about this anymore for a sec. Where you can say next index is equal to n times n, I guess, so that it goes to n, right? Yeah. Oops. I guess that's fine then. We'll just use this, right? But then now we want to pre-process it. So then now, and you could do an n square thing only because I'm lazy. It doesn't really matter because it gets dominated by this exponential thing anyway. So you can say for I in range of n, we can say, okay, so what is the next number that isn't I, where they're not the same, right? So if candidates of I is not equal to candidates of j, then now next index of I is equal to j, and then we break. So pretty simple n square thing. You can actually write this in a little bit of a different way. If you like, you write it backwards, you could do it linear time, but you know, sometimes just write the silly things and then optimize later if you really need to. You don't really need to prematurely optimize everything. And like I said, in this particular case, you get dominated by this anyway. So this is not going to be an issue because n is at most 100. So yeah. So anyway, we start at 0, we start at target, and we start an empty array, and then we just return answer, and we should be hopefully okay. It's a way to kind of exponential things. Oh, I haven't done this one before. That's kind of cool. 1596. Yeah. What's the exponential? I mean, what is the But yeah, there are a couple of ways you can think about this. Like I said, you can also think about this as the number of unique numbers, and it'll be 2 to the n, which I think is technically true. I think in the worst case, actually, in that case, in the way that I'm doing this, right, which I suppose is probably not part of the input. Actually, maybe it's not, because I think that's the thing, right? Is that given the target is equal to 30, right? And so the thing that I showed was one of the worst cases, but another worst case, depending on how you write it, is just the number of distinct numbers, right? And the number of distinct numbers is just going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus ... is equal to plus some x is equal to the max number, which is 30, and then of course the left side is just x times x plus 1 over 2. Maybe I always forget if it's plus 1 or minus 1, but it doesn't matter because it's just roughly you can just say this is x squared. I mean, you can be more precise if you want, but I don't care, right? So then, and yeah, times 2 on both sides. Square root of this is like less than 8, right? So yeah, that means that in the worst case, there can only be 8 unique numbers, where it doesn't break out trivially. So it's like in the worst case 2 to the 8 in this particular thing. Maybe 2 to the 8 times, even like, you know, maybe for each number there's an 8 choice, so you have like 8 times 2 to the 8 or something like that. I don't know. So it could be bad, but apparently not that bad because of the number of unique numbers. Because if you want to analyze this in terms of take no take, then yeah. So yeah, that's how I would think about it. But I mean, of course, it is all just relatively exponential. And of course, I forgot to mention this, but in the end, you still have to do this OF kind of n operation, but the n is very small, like I said. That's all I have for this one. Let me know what and you can also like filter some stuff out, of course. But you don't really have to because you just never take in these anyway. So yeah. And you can also like prune it a little bit if you really like. I mean, I really made no attempt to optimize this that much, right? Like maybe you could have some heuristics and ideas to kind of terminate more earlier. Like for example, you say if next index is less than or equal to target or something like this, right? Is this faster? I mean, it should be, right? Maybe not that much faster, but ooh, Oh, I'm an idiot. This is an index, not a thing. So obviously this is going to be wrong. But what I meant is candidates. That's just me sloppy, right? But yeah, so you could do something like that. And this is maybe out of bounds. So yeah. So you could definitely do something like this and it's slightly faster, but of course you should make sure that it is correct first. So I was just being lazy and I forgot what things are. But yeah, so, but in the end, it shouldn't matter. But yeah, I don't know. I was doing so well before the wrong answer and I still make a wrong answer, so I'm still sloppy, I suppose. But yeah, that's all I have for today though. Let me know what you think. Thanks for watching. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.